In previous segment of concentration units, we have discussed about mass fraction in detail, and also about mole fraction. Mass fraction was related to the mass of solute and solvent, while the mole fraction was related to number of moles of solute and solvent. It was represented by chi. Let me brief here about the mole fraction. Chi A belongs to mole fraction of solvent, while chi B, it is represented by chi, a letter, belongs to mole fraction of solute, and sum of chi A plus chi B will be considered as 1. It was all about the mole fraction. Now, third concentration unit we will discuss here, molarity. What is a molarity? It is represented by capital M, and it is the ratio of moles of solute with volume of solution, and this volume will be taken in liter. This is the equation. What is NB? This is moles of solute, not of solvent, only solute, because B is at the base of the moles. So it represents about the value of solute. So ratio of moles of solute with volume of solution in liter represents the strength of that solution in terms of molarity. Molarity. If we consider volume V equal to 1 liter, that is unit volume is considered, then molarity M will be equal to moles of solute. So what is the definition of molarity? Number of moles of solute dissolved in 1 liter of solution represents strength of that solution in terms of molarity. That is, M will be equal to NB when the volume will be 1. If equal volume of the solutes are taken, then their number of moles will be equal and their strength will be the same. Therefore, for isotonic solution, what is isotonic solution? When concentration of one will be equal to concentration of another. When molarity of one solution will be equal to the molarity of another solution, it is called as isotonic solution, M1 equal to M2. Therefore, we can note down NB1 equal to NB2. In both the cases, the number of moles of solute will be the same. Therefore, we can say WB1 divided by mass, molecular mass of 1 will be equal to WB2 divided by MB2. This will be the equation when number of particles, number of moles will be same. For the isotonic solution, since molarity will be same, therefore number of moles will be same. So in place of mole, we can note down the value in terms of mass of the solute with respect to its molecular mass, and we can find out this equation. So this is all about related to molarity with respect to number of moles and for the isotonic solution. Next, in molarity, since we know the basic equation is molarity M with mass of solute divided by molecular mass of solute into volume of solution in liter. This is the main equation. Here, what is the value of WB by MB? This is the moles of solute. If we take weight with volume, mass of solute, only mass, not the moles, Mass of solute with volume of solution, this is gram per liter. Gram, mass is in gram per liter. This is also a category of strength of solution. If strength of solution will be considered in terms of gram per liter, then the equation will be molarity of the solution with product of molarity of solution with molecular mass of the solute. This will be the equation. If in a given numerical molarity concentration of solution is given, name of the solute is given, then on the basis of these two data we can find out strength of solution in the form of gram per liter. It is the product of molarity of solution and molecular mass of solute. This is molecular mass. Molecular mass of solute, and in previous class in 9th and 10th you have studied already about the molecular mass of solute. It is the sum of the atomic masses of all the component atoms present in a molecule. So this is the molarity and strength of solution with respect to the gram per liter. Next is from the equation 1 molarity, weight of mass of or weight of solute with molecular mass of solute, product volume in liter. It was the equation first. If WB divided by MB becomes same, common, then M into V equal to NB. Therefore, M1V1 equal to M2V2. This is the equation for dilution of a solution. What it means? Suppose in a given solution certain moles of solute are present. In place of solute, if we add some additional amount of solvent, then the solution get dilute. Although the number of moles of solute will be the same as in the previous. Suppose in one container 2 moles of solute are present in 6 moles of solvent. 2 moles of solute dissolved in 6 moles of solvent and this solution is formed. Now in next, the 2 moles of solute are as such, but we add solvent and make it 10 moles of solvent. That is, the amount of solvent is increases, so it becomes dilute. So dilution equation, for the dilution equation, since number of moles of solute are same, therefore MV equal to NB and this value will be a constant in both the cases, in the first equation and the second. Therefore M1V1 equal to M2V2. This is the dilution equation of a solution when M product of molarity and volume of solution will be equal in both the cases because number of moles of solutes are same. So next equation obtained will be M1V1 equal to M2V2. Next equation for molarity is if two solution with different concentration are mixed, are two or more than two. If more than two solutions are mixed, in both the cases the equation obtained. Suppose we will consider first M1 V1 is the for 1 and M2 V2 is the concentration for second. So when both the solution will be mixed, then MV will be the molarity for mixture and volume will be volume for mixture will be equal to the M1 V1 plus M2 V2. Overall strength will be added. Therefore, we can note down molarity of mixture equal to M1 V1 plus M2 V2 divided by volume of mixture in liter. So this will be the equation for the solution when two solutions are mixed with one another, two or more than two. For example, if we take M1 V1 value for HCl, M2 V2 value for HNO3, M3 V3 value for H2SO4, etc. And all these three acids with different concentration are mixed. A mixture is formed. So what will be the molarity of mixture? It will be the ratio of sum of the molar product of molarity with volume of the solutions with volume of the mixture. This will be the equation for the molarity of the mixture when two or more than two solutes are mixed. The overall molarity of mixture will be this sum of product of molarity volume of the solutes then of the solution related divided by the volume of the mixture. So this is all about related to molarity concentration unit of a solution, and in next segment we will discuss about normality.